of all, just out of curiosity, how many people are from the real estate program that are here? Pretty much everybody, okay. Is there anyone from architecture? Yep, okay, yep, and you're in both, I know that. Okay, great. So I'll get right into it. So I had done a few years ago another project with the same partners. So I came at it as a developer and architect, but I had partners who were providing the big funding, and there's another small kind of like a family development company called the Brooklyn Home Company. And they do their own projects, but we had partnered on this project on Congress Street in Brooklyn, and it worked out well. It's a pretty small project, but we did some nice things with it, and we decided to do another one together. And a friend of mine told me lived on this block and told me about these two houses that were for sale. This is interesting how these things happen. I mean, finding a site is one of the most challenging things, and if you just look at the the ads from the real estate brokers, that's not always going to do it. But this was from a guy I knew, lived on the block, knew about these people selling these houses. We thought, this is interesting. You don't often see these two houses come up for sale in a nice neighborhood like this in Park Slope. So those are the two houses, and we came to a deal to acquire those. And then we started talking to people next door to see if we could get another house and try to expand our site, which is the first thing, of course, that you try to do in this situation. And we were interested in this one. It had been abandoned for many years. No one knew where the owners had gone to. We had the help of an Israeli real estate broker named Patrick, who was an incredible detective, and he was able to find these guys up in upstate. They had left in the middle of the night one time and never come back. And so we were able to make a deal to buy that one. Then the one in the middle, that worked out too. We got that one as well. So we had all four sites, which is great. I mean, this block of Union Street has a very colorful past, which I won't get into. I mean, it had fairly unsavory things happening back in the 80s, and now of course the whole neighborhood's going back. So we had the four sites together, 68 feet wide, which is a nice site to have. It's 100 feet long, which is a very typical length, you probably know, in New York City. It's on Union Street, which also has the benefit of being a denser zoning district than the other neighboring districts. It's an FAR 3. Most of the ones around there are FAR 2. So that gives you denser. How many people are familiar with zoning? You guys have had that already? Yep, all right, you've had that right. All right, so you've done that already. So the first thing, of course, we want to do was to do a little quick test fit of the site, see what we can do to it. We know we have our 30-foot rear yard. As you probably know, New York City zoning is very prescriptive. You don't have that much, a lot of the zoning envelope very much of the time ends up being your building envelope, depending on, of course, what your site looks like. This is a 70-foot height limit, and so what the zoning kind of suggests that you do indirectly is do a 7-story building and with a 70-foot height limit. I don't like to do that because that gives you, at best, a 9-foot ceiling height, and often a lower than that ceiling height because you're putting, ventilation and such dropping the ceiling for those things. And an 8-foot ceiling, 8.5 foot, 9 feet, not so great. So I like to do a 6-story building with a 70-foot height limit. That, as you can imagine, means even more that to get all of your floor area that you can, and as you know, you need to use all the floor area that you possibly can. To get all that floor area into that envelope, you're basically building out the whole thing. So you're going to have your 30-foot rear yard. You're going to put your core there in the middle. That's going to be about 25 feet in the front, 25 feet in the back, and then you can do a very quick test fit and see how things are going to lay out, and use that to do a quick pro forma to see how it looks. We did it first with our 2 houses. After we got our 4 houses, we upgraded it to the larger site. And once that was looking pretty good, we took that into the deeper pro forma to really see what we could do. Now, as you can imagine, some of this is fairly predictable. Things like the costs, the soft costs, the hard costs to a certain extent are fairly predictable within a certain margin of error. But many things are not very predictable, such as how you're going to sell these projects, the units, a few years from now. What is the market going to look like? You usually have no idea. You also don't really know how long it's going to take. You usually underestimate that. It usually takes longer than you imagine, which is probably good, because if you really knew how long it would take, you would lose a little bit of the incentive to do the project in the first place, because it takes a long time. So once we were all set up and knew what we were going to do, this is the block, And what are we going to build on this block? It's mostly a block of 2- and 3-story houses still. It has not generally caught up to the zoning that is actually on the block. There's one pretty new tall building on the block, the one that you see right there, and that's what we don't want to do. It's just kind of like a pretty quick and dirty, we might call it developer special, and it doesn't really fit in the block very well. It's not so great, and we want to do something that's a little bit more sympathetic, a little bit more innovative as well. One thing that I did note, that we wanted to do a high performance building. How many of you guys are familiar with Passive House? Okay, so everyone's familiar with that. So as you know, that involves making a low energy building that that has lots of insulation, although the New York City energy code is pretty much catching up to Passive House standards and is approaching them, at least in terms of the amount of insulation you have to use, the air sealing you have to use. We have high performance windows, triple glazed that seal well, and of course we're going to have ventilation because our building is so well sealed. We're going to use ERVs to get fresh air in, and to avoid losing that energy of exchanging air, we're going to exchange the energy of the exhausting air with the incoming air to get ventilation continuously. And of course we're going to have no gas, no combustion anywhere in the building. We're going to heat our food, heat our air, heat our water, all using electricity. And so that both means that our energy, all the energy coming in to do those things, can eventually, it comes now from partially renewable sources of energy, but eventually it'll come from from energy that's mostly renewable, we hope, in the next 20 years or so. And we're preparing for that future by not doing any combustion. Not burning anything also helps because we don't need flues to be continually exhausting air out of the building, which wreaks havoc on your envelope. So recently I'd been on a jury at Pratt, and the students were studying CLT. And I thought it was pretty cool. I knew about CLT, I knew people were using it, but I hadn't really thought about doing it in New York because it just didn't seem like a New York kind of thing. And so I thought, well, this would be cool. Could we use CLT in New York? And how many people are just familiar with what CLT is and mass timber is? Okay, so, pretty much everybody. Okay, well, I'll go through it pretty quickly. Sorry for the review for those who already know about it. But the advantages of CLT is made from taking small dimensional lumber from quick-growing trees from sustainably managed forests, usually out west or north of us in Canada, and using that to get large members of made out of wood that you used to have to get out of old growth trees that are 100 years old that are not really practical to harvest anymore. So these quick-growing trees can be harvested, cut into dimensional lumber, 2x6s, 2x8s, laminated together into larger members that we can use to make structures. The advantage of this is that compared to construction made of steel or concrete, it has lower embodied energy, so that there's not as much energy needed to make it, which is less carbon that is output into the atmosphere and less energy required all around. And it also sequesters carbon. So that means when the trees are harvested, those trees have been sucking carbon out of the air as they grow. The carbon is now the wood, which is mostly carbon, and that carbon then goes into the buildings and it sits there sequestered for the life of the building, which we hope is 100 years or so. And that means that more trees can then grow in the place where those trees were harvested, and they continue to suck more carbon out of the air. So it's pretty much a virtuous process. The other thing about that, of course, is that these buildings can be deconstructed, as opposed to, say, a poured concrete building, which just has to be basically knocked down and carted off to a landfill. These buildings are bolted together and can be, at the end of the useful life of the building, they can be taken apart and they can be disposed of in a responsible manner. Wood obviously is a renewable resource, unlike concrete, where we're running out of sand to make concrete, and steel obviously the same thing. So the other thing is that building on a site is complicated, dangerous potentially, expensive, tricky in New York City where everything is so tight. These buildings go up faster, they go up cleaner, there's less waste. Everything arrives at site ready to go. You put it up, you don't have concrete spatter all over the place. It's much, much cleaner in that respect as well. But the question is, could we do it in New York? So looking at the code, we have heavy timber as a construction type. It's been there for decades. And it does not mention CLT. So the question is, would the New York City Department of Buildings let us do it? Would it be acceptable under code? And there are some precedents. At the time when we were doing this design, these are two finished buildings made out of mass timber and in Brooklyn. At the time we were doing this, they were under construction, they're now completed. The one on the left is made out of NLT, nail laminated timber, which is made out of boards that are nailed together and instead of laminated with glue. And that's an old way of making mass timber that was in the code because it's old. And on the right, we have a CLT building on Green Avenue in Brooklyn, developed by a friend of mine. And that was under construction, and I was hopeful because that building got approval and was going up and seemed to not have any problems, and so it gave me hope that the DOB would let us do it. And we decided to go forward. So one of the things I love about mass timber is that it's made out of plants. And one of the great things about that is that when you look at it, you can see that. You can see the plants, you can see the patterns of the organic process, you can see the depth, the fractal depth of the material. In fact, neuroscience has demonstrated that we respond more emotionally to surface than to architectural, like spatial quality. We normally think of architecture as being mostly about the spatial quality, but in fact, the surface is incredibly important. We respond to it, it engages us, engages our unconscious mind and our emotions. And we respond very well to these natural materials that engage us because in their complexity and the fact that they're non-repetitive, you're looking for patterns. And that has the effect of both stimulating us and calming us at the same time. So it's a very good effect. And so it led to the theme of the building, the concept that guided us throughout, which is this notion of creating life, creating a sense of life in the building. So to take a very quick detour, at the same time I embarked on a little side project to design tiles. And these tiles are hexagonal tiles, also based on the notion of creating life. And these hexagonal tiles, of course, hexagons are found throughout nature, both in organic and inorganic processes. You know, in crystals, in beehives, in fruits and vegetables. It's one of the ways nature likes to arrange materials, molecules. And so we can do that in tiles too. And I thought we could combine patterns in tiles in non-repeating complex ways based on simple units. And so we can design tiles, with these different patterns, combine them, and you can see how they link together to form these larger patterns as they combine. We can do them in different colors, and they can create these different kind of patterns that, again, engage your mind and kind of draw you in and becomes part of the fabric of the building. So back to the design process we went through. Now we're, again, looking at that site. Most of the buildings on this block are 2-story, 3-story buildings. They're masonry buildings of brick, punched openings for windows, 17 feet wide. We have 4 of them. So we thought, okay, our first 2 or 3 stories can have a dialogue with those other buildings. So it doesn't seem like an alien, 70-foot alien craft has landed on this site. So we can gauge those buildings on that lower level, and as we go up, we can then open up more and kind of open up to the views that we have available, and also do a little bit more with the design as it goes up as well. So we started iterating on that and building models that would do that, start with the kind of punched openings at the bottom, then open up as it went up. We experimented with different colors, different kinds of brick, and ended up with this pattern, which again has these bricks on the lower level, has the windows that are actually on the same module as the 17-foot houses on the block, so that there's kind of a correspondence there. But then it opens up, and you see those windows, that the glass above that's oriented towards the west and the north, where we have the central Brooklyn skyline, and to the west, the New York City skyline, which you can see, the Manhattan skyline, which you can see at the west. We decided, even though the first set of bricks were made to match the darker bricks that are more prevalent on the street, but it felt a little bit dark, especially for a big building like that, so we ended up going with the lighter brick. This became our design going forward. We built a Revit model. You guys probably know about Revit. This is BIM, Building Information Modeling, And the whole building was built in very fine detail on the computer, which is good for, of course, the design process. It's how we generate our drawings, and it's particularly important when we're doing something in mass timber, because this model is used to actually build, to fabricate the elements for the building itself. We also technologically use VR. So this is a great tool. This is, again, just a simple consumer Oculus headset. And then we take our model and we dive into it. We go inside and we walk around the spaces. We make sure they feel good. We see how the ceiling height feels. We see how the materials feel. We see how the proportions feel. Nothing, there's no substitute. It's looking at renderings, looking at physical models. Nothing substitutes for actually going into your building and feeling it. How many of you have experienced walking around a building with a VR headset? Have you all done that before? Okay, so maybe half. But if you haven't done it, it's transformative in terms of really understanding what a building is going to feel like when it's done. So we ended up with this design. You can see down here the tiles that we have in the kitchen, the tiles there in the lobby, and you can see the CLT, the mass timber elements being exposed as well as part of the design. We have the front entrance with the brick and the lobby where you have to come into a timber entry here to kind of get you into the building. Then going upstairs into the apartments, we have our living rooms. This is one of the upper floors with the glass looking out over the tops of the other buildings and looking towards the kitchen. And these are, pretty open apartments, and as I said before, exposing the CLT wherever possible, so that becomes part of the environment. Let's go back to my concern I had with the Department of Buildings. So in October of 2019, we got approval from the Department of Buildings, and that was a great event because we had been working for many months to do that. We had to go through a long plan review process, long energy review process. These are not quick processes to go through, and so it was great to get that approval. However, it became clear to me in the way those processes had gone that I don't think anybody at the DOB who looked at our drawings really registered that this was a mass timber building. It did not seem incredibly clear. I mean, it was all there in words, but they don't really look at your structural drawings because they don't really get that. They look at certain things and they ignore the great majority of what your building is made out of. So I was like, I don't think they really know it's a mass timber building at all. So then it becomes, well, we have the approval. Should we just go forward, just like my friend on Green Avenue did, and just go and build it and see what happens? But here's what I learned in the meantime while that process was going on. My friend at Green Avenue had his site shut down. DOB had rescinded his permit and shut down and given them a stop work order. I imagine someone from the DOB driving by the site one day and looking up and saying, oh my God, there's a big wooden building going up in Brooklyn. Where did that come from? And that's, that led to them being shut down. So I was like, I don't want that to happen to me. It's too risky when you're doing a project like this. In fact, they eventually worked it out, but it took them 6 months, and they were tortured by the Department of Buildings in the process of getting their permit back. So I thought, okay, I'm going to come clean. I'm going to go to the Department of Buildings, get a meeting with these guys, and see if I can say, okay, I'm like the guys on Green Avenue. Can I work with you in advance of starting my construction so that we all start on the same even path here? So I prepared my presentation, all of my data about char ratings for heavy timber structures. They don't burn. When I talk to people about it, I'm like, yes, wood burns, but have you ever tried to light a big log in a fireplace? You can't just hold a lighter up to it and light on fire. It's actually very difficult to get heavy wood members to catch on fire, and that's what heavy timber is, or mass timber does. It resists catching on fire for quite a while. And so I prepared all my things. I tried for months to get an appointment with them, and finally in December, I got an appointment with the Department of Buildings. I met with 5 high-level administrators. They're all, perfectly nice people to sit and meet with. But they didn't smile much, and they didn't have much to tell me. And I found out a couple weeks later that nothing doing, you can't do your building. And sure enough, a few weeks later, I got an email that my approval had been rescinded, and I no longer had approval on this building. So I didn't really give up. I was like, I'm going to keep going, and I'm going to go up the chain and see what else I can do. Meanwhile, we had gotten our demolition permit, and we started demolition of the houses. And that started at the end of 2019, and it was going perfectly well until COVID hit in the spring of 2020, which which you know very well, and everything got shut down, including our construction site. So we got shut down about maybe 2/3 of the way through the demolition process. But meanwhile, while that was going on, I learned something else, which is I met a new timber vendor called Vaughan Timbers in Washington, and they had another kind of mass timber, which is called blue laminated timber. Now, you guys know that cross-laminated timber is known for the layers, like it's structured like a piece of plywood blown up in scale. You have the fibers oriented in cross laminations. They go this way, then they go that way. In glue laminated timber, they all go the same way. All the members, like these 2x8s, are compressed together and glued, and that's how you make your planks that form your floorboards. Glue laminated timber has been around for a long time, and it's in the old version of the code. By the way, if you don't know, the new version of the New York City building code came out early this year. It was supposed to come out in 2020. It was delayed because of COVID and all the other crap that was going on in city government. And it finally came out, and it does allow CLT with limitations. But this was before that, and so I realized that this was in the code, and this was in my back pocket in case they would not let me use CLT. As it happened, I worked for a while, and I ended up having a conversation with the commissioner. I got my councilman involved, who's a councilman in this district. We had this big conference call on Zoom, and that was in the summer of 2020. Summer of 2020, and he said, "I'm sorry, I'd like to help you. CLT is great, but no way. FDNY will never let me do it." So that was that. So we knew we were going to do GLT. So we started our engineering process, and doing a mass timber building like this is really interesting because so much of it is prefabricated in a factory off-site. So I like to liken it to building a very large piece of IKEA furniture. So when you get IKEA furniture, all the pieces come and they have these kind of funny notches and holes and all these little pieces. And then you put them all together and you put the little hardware bits in, and it all kind of comes together pretty quickly with your special tools and all that. And that's a little bit of the way these buildings are put together as well. But because each building is unique, you have to go through that process of pre-engineering every single notch, every connection, every hole where every pipe is going to penetrate or every duct is going to penetrate. So all of those markings there, green, the green is the plumbing, I forget what each one is, but you have plumbing, you have electrical, you have mechanical, you have sprinkler. They're all there, and all the chases are being cut, and every connection is being engineered, and we had many, many hours on Zoom with the engineers, the vendor of the timber, our contractor, and my office, all talking about all this stuff so that everyone could be on the same page. And they're using our Revit model, which had to be built within a tolerance of 1/8 of an inch. So this wasn't like a quick 3D model just to see what the building's going to look like. This is actually making it absolutely precise because this model is going to be used to fabricate these pieces, which would be showing up later on a flatbed truck to be assembled on site. So finally, in February of 2021, our timber shows up. This is that first day after we'd made the foundation, which was the foundation, of course, is concrete. There are no foundations made of mass timber at this point. And timber started to go up. They came to a pretty good rhythm where there'd be 1 week of flatbed trucks arriving. They would offload with a crane, this big crane on this little Brooklyn street, the pieces onto the site. And they would be assembled, lifted into place. Guys would sit there and bolt them in. And it went up really quickly, really cleanly. It was really incredibly gratifying to watch that happen. Then after that week of assembling a floor of mass timber, they would do the core and the lot line walls. You see those on the lot lines, there are those firewalls made out of concrete block. FDNY is not going to let us do mass timber cores or lot line walls anytime soon. So even if you do a CLT building under the current code, you're still going to be doing concrete cores and concrete firewalls because they don't trust, even though data does suggest, and people do them in other locales, that it'll be fine, that it resists fire, for the time that you need to get your required ratings. It's not. FDNY is not going to let us do it because they don't want firefighters roaming around wooden, up and down wooden stairways. So that was an interesting little process, and so that went a week of concrete, a week of timber, back and forth for several weeks until we got to the top of our 6-story building. You see the top of the Guatemalan flag from when they topped out. this is a nice overview of like about halfway through that process. You can see what the site looks like as it went through. And you'll see those metal straps. So we have all those timber deck panels that have to sit on the top. Those straps tie everything together so that the whole wooden structure can act as a diaphragm to resist lateral forces. So normally you'd have like reinforced concrete decks, and that would take care of that. In this case, we have the wooden decks connected by those straps. That's something we had to add because we weren't using CLT. CLT is better at doing that kind of stuff, but glue laminated timber only works in one direction, so that required those straps to go in the other direction. Nice image of how those panels would go in. They drop into place. Guys would go with the screw guns and go and screw everything down. It's just done by a few carpenters. It's a very nice and neat operation. And it looked great going in. It was very satisfying to see these kind of spaces start to take shape. Now, of course, our goal from the beginning was to have these ceilings in the structure all be exposed. So when you're in your space, you have this nice tall ceiling, and you have the timber ceiling. Of course, the only way we could accomplish that is by putting all the other stuff that needs to go in your building in the side spaces. So you have an uncountable number of ducts, of conduit, electrical conduit, you have plumbing lines, sprinkler lines. All these things have to be packed into your building. These are the modern requirements. And so all of these are packed into the non-major spaces, your corridors, your bathrooms, your closets. All of those are packed to the gills with all these things. And so normally, when you're doing a regular building, your engineer says, oh, great, okay, here's my air conditioning system. I'm going to put the ducts here. I'm going to put the conduit here. I'm going to put the sprinklers here. It's pretty straightforward. In our case, we had to go through and spend many, many hours plotting exactly where every duct run was going to be, where every sprinkler line was going to be, where we were going to run the electrical. Of course, we also have, in addition to regular HVAC stuff, we have the ERVs, the energy recovery ventilation that's distributing the fresh air. That's what those kind of flexible hoses are. So we had to find places to run those as well. It's a lot of stuff that had to run in those limited spaces. And so here's a little shot of during the construction. You can see we're doing our air sealing. There's our smart membrane. So we have a stud wall that has, it's filled with insulation. We're using mineral wool insulation. Then we have another layer of studs, that skinnier level of studs. That's our cavity wall, and that has all of our electrical running in it. So that's a way of not having all the electrical interrupt, or if the plumbing lines have to run, they run in there as well. That's a way of avoiding our insulation being sliced up by those lines running through there. And that's an ERV on the right. That's providing our ventilation. Another shot of the building in mid-construction. There is the top floor with the view of Manhattan skyline in the background. There you see the planks being lifted into place. We have beautiful bricks on the outside. These are bricks. Excuse me. We have beautiful bricks on the outside. These are bricks from Denmark by Peterson Tegel, and they are handmade bricks that have a lot of variation to them. So they are also kind of part of this concept of creating a sense of life, of unevenness as opposed to monolithic qualities. We got to also experiment a bit with some masonry, doing some core building here at the entrance. You can see there how we have the balconies come out, and we reveal the timber coming out at the underside of the balconies. If you remember the tiles, we had the tiles made in Turkey, and those are those started arriving about a couple months ago, and those have just been installed recently, and that was really cool to see too how those got made and installed. And those that's a kitchen, that's some of the bathrooms get the blue tile, and then we have as they look face on, and then we have them in the lobby as well in green. So the spaces are starting to take shape. These are kitchens going in. Again, you can see how the timber ceilings are looking. This is very top floor, the penthouse. These are the beautiful glass walls. These are, again, high performance glazing with triple glazed windows. And then we also have really great lighting. We have these very skinny LED strips that are very minimal but very bright from a company called Kelvix in Washington. We spent a long time finding those as well, and this is a way of, I didn't want to put big light fixtures up there, but this is a way of getting our lighting in a way that really creates this great glow in the apartments, very warm, and illuminates the wood as well, with a very minimal means. We have a roof deck on top that has the great views of the Brooklyn skyline and the Manhattan skyline. And of course, on the back side of the roof, we have photovoltaic panels, so we're generating a bunch of electricity on the roof at the same time, which will help with all the loads for heating, cooling, and hot water in the building. And that's it. Thank you. So I will be happy to take some questions if there are questions. Go ahead.
In some of my research into CLT, there's a lot of comments about like sound issues with floor to floor. Did you do anything to mitigate that?
Yeah, so so the planks are about 8 inches thick, and then on top of that, as soon as the planks went down, on top of that is an isolating layer. It's about a 10 mil layer of it's like a resilient material, like a pad that's continuous. And then on top of that is 2 inches of lightweight concrete. And that isolating layer is to prevent footfalls from coming through. If you just had the CLT itself, or in this case GLT, if you just had the mass timber plank itself, you would hear every footfall of your neighbor upstairs walking. This should take care of that. And on top of that 2 inches of concrete, we have our wooden floor that you saw in the pictures. And that concrete is also necessary for our fire rating, because we have a 1 hour fire rating in between floors, and that's a well-established fire rating, the timber deck, and then the concrete on top of it. Yeah. Yeah, so NLT would have been easily usable, but it's an inferior material. It's hard to, have you seen it? Yeah. So what they basically do is they just take like 2x8s and they line them up, just in a row, and then they just nail them together. But if you look at the bottom of it, for example, you know how a piece of dimensional lumber has a little fillet around the corners, like it doesn't have sharp corners. So when you put them all together, it really looks like you just took a bunch of boards and stuck them together. You can see the fillet, between each board, and so you see those it really pronounces the gaps. If you look at here, you can see all these have been planed, so you have a very, very tight connection. Each plank really looks like a monolithic object. Of course, you can see the boards, but they really come across as a pattern rather than actual just boards stacked up. So it just looks a lot better. It's, I think structurally it would have been very similar, but it's a much better looking product in the end. Yeah.
I know you said you could save a lot of time with your construction period. On the other end, your design phases, how much additional time does it take to have this so highly coordinated before you start building the
Yeah.
ground? And then just one other question is, was it difficult to find GCs and subs that are comfortable?
Yeah. Good question. So, so there's pre-engineering, and the question is, well, does that take a long time, and does it adversely affect your schedule because you're taking that time? And I would say that it took a long time, but it happened at the same time as the construction was happening. So it was happening concurrent with other processes that we're doing anyway. So it wasn't actually holding up the schedule. We were not waiting for that process to happen. So we were doing our demolition at the same time, and the demolition took a long time. I think it took about 8 months or something like that to finish all the demolition. Well, we also were interrupted for a couple months, but we never were sitting around waiting for that engineering process to happen. We finished demolition. We got the demolition signed off, and then we had to do the excavation and foundation, which also took a few months. So we were doing all those concurrently. So by the time we were finished with our engineering process, it was just in time for them to get those planks out. And by the way, it was a just-in-time kind of methodology. So we started from the bottom and went up. So when we released the lower floors and had those in production and on their way to the site at the same time as we were still working on the upper floors. And so it was a kind of a real-time process. And so as a result, it didn't, that engineering time didn't add any time to the overall schedule. It just kind of dovetailed what was going on anyway. All right, now the other question was finding a contractor. So there were no so first of all, there were 2 contractors that had experience with mass timber, which were the 2 contractors doing those 2 buildings I showed you early on. And I spoke to both of them. The first one, and funny enough, neither of them was like a mass timber contractor at any connection to it. They were fairly random in that they'd been selected by those teams. The first one was a contractor that had done mostly suburban work on Long Island, doing like mini malls and things like that. Why they were doing that building, I still had no idea. We talked to them, we got an early bid from them. It was not even slightly competitive, so they were out. The second group we were interested in working with, they seemed pretty good. They were doing that CLT building, but they got fired by the team, because I know the guy who was doing that building. He's like, yeah, we fired them, they're crooks. I mean, I'm sure they weren't really crooks, but they had falling out and they got fired, and so we decided not to work with them either. And so we found these other guys had done another building with my development partners, and they seemed like good guys, and they were not used to doing a high-end building or complicated buildings. They did very normal concrete buildings. They had their own concrete company. They were used to doing concrete buildings, white box, vanilla kind of buildings. And so we said, can you do this more unusual kind of thing? And they're like, yeah, we can do it, sure. And so one of the nice things about it is it's actually not that hard. You know, that engineering stuff that I was talking about before, that's the hard part, to figure out all those things. Once it's figured out, once it arrives on site, I mean, in the same way that IKEA furniture makes all of us builders of furniture, even people who are not actual mill workers, it's kind of an equivalent for contractors. The stuff shows up, it's ready to go, it drops into place, they put the bolts in the holes that are already pre-drilled, it's kind of all ready to go. And so they just had carpenters who had never done this before in their lives, you know, doing the first floor, there was a little bit of a learning curve because it was the first time they'd done it. But once they figured it out, they were like, okay, we get it, and they just rolled through, and there were no problems, and no glitch. Actually, the only glitch is a few of them came, like the connectors would be like on the wrong side. The fabricators had actually made the mistake, just like some guy in the factory had misread a drawing or used the wrong file or something. So there are a few little improvised elements that had to be dealt with in the field, but for the most part, everything was ready to go and came together very easily, and it was, you know, once they got started, one of the easiest things about the whole process, actually. And in fact, we talked to the contractors, because at first they were like, man, if this were a concrete building, we would just do it so quickly, like before it started. We know how to do concrete, it would just be so fast. But by the time we got into it, they said, actually, that's not really true, because when you do concrete, when you do concrete, you have to set up your formwork, you have to pour the concrete, you have to wait for it to cure, and you have all those shores that are holding up the concrete deck while it's curing. Then you can remove the shores, and then you can go up and start the next level and start doing your new deck. So when you factor in all those things, it's actually faster. They admitted, these guys who are concrete people, they admitted it was faster than doing one of their concrete buildings that they were very familiar with. So that was actually a good thing. Yeah, Jessica.
It's so interesting, thank you. It's actually funny, this is where my kid went to daycare for 4 years, the site.
Oh, right.
I wanted to ask, is this something you want to do again? And like you have this specialized knowledge, and do you think it will be like just so much faster coming over it?
Yeah, so I definitely want to do it again. And this time I think we'll be able to use CLT, which, you know, and I'm perfectly happy with what we got out of our GLT on this project, but I think it would be even better to use CLT. It involves some engineering problems. When you have a big cutout, for example, because GLT is a one-way system, when you make a cutout, you have to reinforce that. There are a little more gymnastics you have to do to make it work. So yes, we want to do another CLT building, and I think the whole pre-engineering process will be much easier having gone through it once before, now that we're familiar with that and how everything gets put together. And you know, I like to think that we would do it. We have a very good relationship with this contractor that we've been working with, and they will now be very familiar with it as well. So that would be a good match. Yep.
Like kind of building off Jessica's question, like when you look at a project now, like normally you don't start a project thinking going in with like, oh, it's steel frame, oh, it's like concrete, like, and with GLT, with like
So one of the things that was a little bit difficult at the very beginning was the financial modeling for it, because people were not familiar with it. And the good thing is that we could talk to the CLT vendor and we could get costs for them pretty easily. So we could give them our drawings and say, can you give us a quick take on what this is going to cost? And they were able to do that, at least for the material. They couldn't say what it would cost to erect because that's up to the contractor, but they could at least say what the material is going to be. And it became clear pretty quickly that it was very affordable. Like, the material is not incredibly expensive. And the cost of erecting it, we thought, would not be so bad because, again, the cost of erecting something is essentially the time it takes, the number of people you have, and then the cost of materials. We knew what the material would cost. We gathered from talking to the vendor that it would not take a lot of people a lot of time to install it. So it seemed to make a lot of sense financially, again, early on, so we could factor those costs in. I mean, the truth is, any building, you have to factor in the cost, whatever your construction system is going to be. It's just that, you're typically fairly limited if you're doing a conventional building. If you're doing a conventional building, you're going to do steel, you're going to do reinforced concrete, and there are a few choices within that, the little flavors that you select. But you factor that in when you're seeing your costs are. Ultimately, when you're doing your initial pro forma, you're making that a cost per square foot, and that factors in. And it became pretty clear that it was not going to vary by very much. And in fact, if you think of things that changed during the, fluctuated in cost during the whole process, that was one that was actually very predictable and came in pretty much on the nose of what we predicted it to be, because we knew we were buying those materials and what they would cost and how they'd be put together. Does that answer the question?
Yeah. Thank you.
And Eric, you might also say that, Greg, you don't have an architecture background, but typically architects, when they are designing, do think about how you fit construction.
Oh, yeah.
It's not just that you do the design and then you work out
Yeah.
because those decisions, just like this is a very dramatic example, you've got to take that into account in terms of how you end up here.
Yeah, so that's right, Patrice. And to expand on that, it has an effect on how the module of your structural system determines a lot of how you lay things out. What's the spacing of your columns? How far can you span? And you design to be efficient too. You have your building is on a certain site, it's a certain size, and you are dividing that into structural modules. Like, you have columns occurring at certain places, structural walls occurring at certain places, and you want to have that be as efficient as possible, and avoid like, oh, we have a half bay here because the site's slightly shorter than it would be if we had like 3 or 4 full bays. You want to make everything work together. So architects are always thinking about that. The other thing I didn't mention is we have parking on this building. We have zoning requires parking. We have a parking lot at grade in the back. We have electric car chargers at each of the spaces. And particularly when you're doing parking, the module is incredibly important because you have to be able to fit parking spaces between your columns. So that's also, comes into consideration very early on. Yeah.
A few questions. One, during the construction period, were you concerned about rain, it being rained on? And I have two speculative questions. How do you feel about mass timber being deployed on larger span buildings or taller buildings? What are the kind of engineering challenges? I know everyone's, if your arms raised, everyone's trying to do it, but I think people encounter different types of challenges. And my last question is, do you have concerns about longevity in terms of keeping light and moisture, especially when it isn't used?
Yeah. So those are good questions. So in terms of exposure during construction, it was something I was very concerned about. We know that the timber can be out in the rain. I mean, they do this stuff in like places like the Pacific Northwest where it rains all the time, and it's exposed. As long as it gets to dry by the time it's enclosed, it's okay. Obviously, you wouldn't want to leave it out for a long time, but just like in any lumber yard where stuff gets rained on and then it dries, it can tolerate a good amount of rain during that process. But I still wanted to protect it, and so when something was going to be out for a while, for whatever reason, we had them tarp it. For example, most specifically with the roof. So once the roof was done, and because everything else was happening pretty quickly. And remember, as soon as they laid the planks for any given floor, they'd put that mat on and then the 2 inches of concrete. So that was a pretty good protection against the elements for, you know, for a short time at least. When they did the roof, I wanted it to keep that protected, and so they put essentially tarps on top of that until the real roofing came on. Then eventually we did a real temporary roof to go on, because for whatever, you know, I didn't even get into all the crazy logistical issues that came into account after the shortages during COVID and all that, but after COVID came, so all that started to happen. You couldn't get tapered insulation for months. So it took us, I think, 10 months to get tapered insulation, which we needed for our roof. So we needed to do a temporary roof on top of the deck in order to keep the weather out. And then I was very careful about what would be exposed during the life of the building. So we have the deck exposed on the bottom. So you can see the underside of that balcony is exposed timber, but that's not going to get any rain on it. It will, you know, it's subject to atmospheric moisture, but that's not going to hurt it. There's a sealer on it, which is not, you know, the sealer is good for generic moisture in the air and all that. You know, if we were getting hit with rain day after day, year after year, that would eventually take its toll, probably. But nothing is actually going to be exposed directly to the elements at the end. And then, you know, this is all brick on the facade, and at the edge of the balcony is going to be a metal kind of flashing that's going to protect the edge as well. Was that the end of your question? There's one more?
Yeah.
Oh, the arms raised.
The arms raised,
Yeah.
Do you see?
With height. So, so right now we're, you know, New York City. I mean, there's International Building Code and there's New York City Building Code. So right now, this is all under the kind of, you know, these CLT buildings would be done under the construction class of heavy timber, which is not what we ideally want. We don't want in that category because that's a very limited category. But that's where it is for now. So you're not going to be seeing tall buildings made out of timber in New York City anytime soon. This is all being driven by FDNY, which is very conservative and very reluctant to allow any of this stuff. It's not really the DOB proper that doesn't want people to build in timber. And so, you know, I was at various talks given by the, you know, Woodworks, which is the advisory committee. They basically invited, I saw, you know, the people from FDNY were there, these officials. They were trying to explain to them why this is actually safe. It's being done all around the world, and it's a safe thing. But they've been very slow to come around to it, and so you will not be seeing tall timber buildings here. But we do have them in other areas of the world, even other areas of the states. You know, we have them in Minnesota and, you know, other places. So, you know, it's definitely feasible. It's being done, and it's, you know, they have to. There's some funky things happening with construction classes. You see people in other places in the States putting them on plinths of other materials. You know, so if you're limited to 6 stories or 8 stories, they'll do a plinth of, you know, concrete and steel, and then put the timber building on top of that. You know, so there's different things that people are going to be creative in terms of getting around the limitations of the code. Yeah.
Now that this is written into the code, is it just immediately easier to get things passed, or is there a learning curve? Do you have to spend more time with the DOT officials to kind of walk them through when you do plan reviews? Same as the construction.
Well, the truth is, nobody knows yet. I haven't had an exam under the new code. My experience in the DOB is that the people you talk to have a pretty poor handle on the code as it's existed for years. So to expect that they're going to be very familiar with the new code is not really, I don't expect them to have any idea. So it's going to be a learning process for them for sure. I'm pretty certain about that. But the funny thing is, I think they're just going to be able to check the box that this is CLT, we have CLT in the code. They're not going to sit there and evaluate, oh, is the span proper, and are they like using it in the right way? Because they don't look at stuff like that. So they're going to, you know, but it's going to at least avoid the DOB showing up at your site and putting a stop work order and shutting you down. And you're going to be able to get things approved and with CLT. There are other factors they're going to be looking at. I mean, there are more things to the 2022 code than simply saying, yep, it's okay to use CLT now. And so we're going to have to look at those in more detail and see what happens. I think this is a little bit in the weeds, but I got this changed to a different construction class, to 3A, which is a better construction class in terms of, you know, heavy timber is, again, it's a vestige. It's like a, this weird vestigial class from like the early 20th century, early industrial revolution, almost like the early 20th century warehouse buildings. And so it asks for things like you can't have drop ceilings. There's many things that you're not allowed to have in a heavy timber building. So getting this into a different construction class was important, and I still don't see how we're going to navigate that. I haven't tried that yet with the new code, and we're going to see how that goes.
Very exciting and very inspiring. Thank you very, very much.
Thank you guys for having me. It's good to be here.